Hi everyone, this is Miss Perenboom, and today we are looking at Learning Target 3A. This is day 2 of that learning target, and we are continuing to solve one-step equations. Now, we've already spent a day working on solving one-step equations using addition and subtraction. So today we're going to start looking at solving equations that involve multiplication and division. Okay, so our first key concept for today is what we call the division property of equality. And essentially it just tells us that as long as we divide both sides of an equation by the same number, we're going to produce an equivalent equation. And that idea that this equation is balanced, so as long as we do the same thing to both sides, we will keep it balanced. That's the whole idea here, right? We want to keep the equation balanced. All right, so if I give you the equation 3 times x is equal to 15, first of all, I know this is multiplication when I see a number next to a variable. There doesn't have to be a symbol or anything. We just know that that means multiplication. And so I'm guessing you guys already know the answer. You probably already know what x would have to be. But again, we want to know, how do we show the work for that? How do we support or justify the answer? Okay, so first thing I'm going to do is I'm going to draw the line down the middle. Okay, and my reminder over here, remember, it's not just a solution, but we're learning those steps. So line down the middle, and then I'm going to think to myself, how do I get x by itself? How do I undo this multiplication? Well, the inverse operation of multiplication would be division. And so I'm going to divide both sides by the same number. And I'm not just picking a random number, I'm picking the number that's I want to get rid of. So I want to get just x by itself, so that means I get rid of the 3. So I'm dividing both sides by 3. Okay, it's going to cancel out over here on the left side, and when it does that, because if I multiply and divide by the same number, that's just equal to 1. So I now have 1x is equal to, and then on the other side, 15 divided by 3 is 5. So x is equal to 5. And again, I know that you probably already knew that answer, but it's how we show the work, how we justify it. That's what we're learning here. All right, let's try a few more. One other quick reminder is that as we're using division to solve, please use a fraction bar to show division as opposed to the little division symbol with the 2 dots. All right, so this next one, we have 8 times x is equal to 88. So first step, put my line down the middle. And then to undo this multiplication, I'm going to have to divide. And so I'm going to divide both sides by the same number. So I will divide both sides by 8. And again, I'm picking the number that's being multiplied by x because that's what I want to undo. 8 divided by 8 cancels out to 1, so I'm now left with x on the left-hand side, and on the right-hand side, 88 divided by 8 is equal to 11. So we do the same thing to both sides, and then we simplify and get our new equivalent equation, which is then solved. All right, so let's try another one. Negative 13x is equal to 65. All right, so first thing, I'm going to draw my line down the middle. And then I need to undo that multiplication. Now, a common mistake here would be to accidentally add 13 to both sides because we see this negative sign out in front. But remember, the operation happening between the number and the variable is multiplication. So again, we're going to have to divide both sides by negative 13. Okay, so always divide by the exact same number that you see as the coefficient in front of the variable. So in this case, it's negative. Negative 13 divided by negative 13 becomes positive 1, so that leaves me with just 1x. And on the other side, 65 divided by negative 13 gives me negative 5. All right, let's try a couple more here. For this one, I've got 54 is equal to 6 times a. All right, and so what would be that first step that we would need to do? So after we draw the line, what inverse operation are we going to do to get a by itself? Okay, hopefully you said that we're going to divide both sides by 6. When we do that, it's going to cancel out over here on the right, leaving me with just a. And on the left side, 54 divided by 6 is equal to 9. So 9 is equal to a. All right, and one more here. I've got negative y, or the opposite of y, is equal to 16. Okay, this one doesn't have a number in front of the variable. However, there is that negative sign there. And when we say we're going to solve the equation, that means we need to get the variable by itself with a coefficient of 1. So I need 1y, not negative 1y, but just 1y. So to get rid of that negative sign, I'm going to rewrite that equation, and I'm going to make that a negative 1. Why? Because if we don't see a number in front, we know the coefficient is 1, and since it's negative, we'll write it as negative 1y. Okay, so now I can see that there's multiplication happening here between negative 1 and the variable. And so my next step would be to divide both sides by negative 1. Cancels out on the left here, leaving me with y is equal to negative 16. So essentially, we just needed to change the signs of everything to get y as being positive 1y, and then that made the 16 negative. All right, so that was solving using division. Now let's look at the multiplication property of equality. So this essentially says the same thing, only this time if you multiply both sides of an equation by the same number, it will produce an equivalent equation. So again, as long as we're doing the same thing to both sides, then we're going to be okay and it's going to stay balanced. All right, so if I had x divided by 2 is equal to 13, okay, and again, remember, it's not just about the answer, it's about how we show the work. So line down the middle. To undo division here, to get x by itself, I'm going to multiply. So since I'm dividing x by 2, to undo that, I'm going to multiply both sides by 2. And I can show multiplication not by using an x, because that's going to look like a variable, but instead either use parentheses or use like the dot symbol. All right, so multiplying both sides by 2, it's going to cancel out here on the left, leaving me with x is equal to 26. All right, the next one, I've got x over negative 4, or x divided by negative 4 is equal to 3. So again, line down the middle, and to get x by itself, I need to use an inverse operation. So the opposite of dividing by negative 4 would be to multiply by negative 4, and I do it on both sides. Multiplying and dividing by the same number cancels, so x is now equal to, and then 3 times negative 4 is negative 12. All right, and our next one, negative 11.2 is equal to a divided by negative 10. So we have a decimal here, but that's okay. We still solve the same way, and you guys can use a calculator in this unit. So if you're not sure about something or want to double check, feel free to use a calculator. All right, so to get a alone, I need to undo this division. So I'm going to multiply both sides by negative 10. It'll cancel out here on the right. And on the left side, negative 10 times negative 11.2, that's going to give me positive, and then 112. So positive 112 is equal to a. Okay, 2 more here. So negative 11 is equal to n divided by negative 3. Okay, so after we draw our line down the middle, what inverse operation do we have to do to get n by itself? All right, hopefully you said you're going to multiply both sides by negative 3. And so when I do that, it's going to cancel on the right here. And I'm left with negative 3 times negative 11, which is equal to positive 33. And 33 is equal to n. And our last one, 17 is equal to k divided by negative 5, excuse me. So line down the middle, and what inverse operation do we need to do here? Okay, hopefully you said we're going to multiply both sides by negative 5, and it'll cancel on the right. Negative 5 times 17 is going to leave us with negative 85 is equal to k. All right, so I'm going to have you guys try these two on your own. You're probably going to need a little scratch paper to write down and show your work, but then you can enter in your answers and then do your reflection to wrap up. All right, so before you go, please record something you learned or were reminded of, and any questions that you have, and try to record one thing at least for each prompt. Okay, thanks for watching.